Today I'll teach you that how to configure indirect neighborship, right? So to configure indirect neighborship, of course we must configure a IGP just to make sure that okay, R1 can reach R5. Let's say we want to configure indirect neighborship in between R1 and R5. So I'll be running here EIGRP 100. Let me do that. Router EIGRP 100 node assembly network 12.1.1, and then it's loopback only, nothing else. Its lane I'll advertise that in BGP only. On R2 I'm going to say router EIGRP 100 node assembly network. Similarly on R3 router EIGRP 100 node assembly network. Similarly on R4 router EIGRP 100 node assembly network. Then I'll move on R5 and I'll say router EIGRP 100 node assembly network 45.1.5 network 5.5.5. Fine. Now we can see that from R1 we can easily reach the loopback of R5. We can easily ping with that ping 555 source is loopback 1, which means that we have reachability in between R1 and R5 with using their loopback addresses. So first of all I'll configure BGP peering between R1 and R5. So to do that, router BGP BGP 100 neighbor is going to be 5.5.5 and remote AS, let's say it is still 100. There I'll be saying neighbor with 5.5.5, update source is what? Loopback 1. You understand? And then I'll move on R5. Similarly I will be saying router BGP 100 neighbor is 1.1.1, right? And remote AS is going to be same as previously 100. Neighbor is gonna to use loopback 1 as update source, right? So this time we will see that R1 and R5 they will form IBC peering between each other with using their loopback addresses, right? So now IBC peering must come up in between R1 and R5. Just wait for a moment. Fine. So now neighborship has came up, right? So neighborship has came up. Show IP BGP summary. So neighborship has came up, but we didn't advertise anything into BGP. Now what will I do? Router BGP 100 network 192.168.101.0. I have advertised its lane into the BGP. Similarly, I will move on R5 and I'll say router BGP. You understand? Router BGP 100 and then I'll say network 192.168.105, right? .0. So now on R1 I must be able to see show IP BGP 105 over here. Yes, and it is best. It is best. That is why show IP route BGP. If you see, if you look at this, you will find 105 available in its routing table. Similarly, I can move on R5 and I can try to see show IP route BGP. Routes learned through BGP. Now I can try to ping with 101.1. You understand? And what is it saying? Unreachable. You know why? Because R5 will forward this traffic towards R4, but R4 doesn't have this 105 available in its own routing table, right? That is why it is not possible to reach now 101, and this is called black hole, right? So to avoid it, what can we do? We can enable synchronization on both routers R1 and R5, and then you will see that R5 is if R5 receives anything from IBGP neighbor R1, then R5 will not make it best, which means that even R5 itself will not install that prefix in its local routing table. And right now, if R5 is having one another EBGP neighbor, then it can forward these prefixes towards that EBGP neighbor as well. That's why I said that they will, the customer edge routers, they will exchange their prefixes with each other, but still they won't be able to communicate with each other. So this is called black hole, right? So to avoid this situation, actually we were having synchronization. So after enabling synchronization, it will be mandatory for us to perform redistribution. If you perform redistribution, then there will not be any black hole, right? So this is the uses of it. How can we solve this problem now? Do we have any solution for it? तुम क्या करना है आज?
Last name, sir.
Huh?
Last.
Fine. So is there any way to solve this problem? Yes, there is. We can solve this problem by using GRE tunnel. We can solve this problem by using GRE tunnel, right? So what can we do? Let this BGP configured, and let's, along with BGP, let's configure one tunnel as well. Interface tunnel, right? One IP address, let's say here it is 1.1. You understand? And tunnel source is going to be its own loop path, that is 1.1.1. Tunnel destination we can define 5.5.5, and they have reachability, right? Similarly, I will move on R5. On R5 as well, I'll configure one tunnel interface. I'll be saying that its IP address is 1.2, right? And tunnel source will be, tell me to 5.5.5, and tunnel destination would be, yes. So now tunnel interface will come up, and now you can see that from R5 we can ping with 1.1, right? Now the point is, see, on R1, look at BGP table. 105 is learned from 5.5.5 because it is my neighbor, right? But I can modify its next hop address. And what can I do? In place of this 5.5.5, I can configure its next hop address to reach 105 as the tunnel interface of R5 itself. In place of 555, I mean right now its next hop address is the neighbor's address, right? Because we are having neighborship with 5.5.5. That is why this 5.5.5 is coming as a next hop address. But in BGP we can modify next hop address anytime with the help of route map. In BGP we can modify next hop address anytime with the help of route map. In previous class I taught you that how can you modify next hop with the help of next hop self command. But next hop self command can be configured only on edge routers, right? Like if you are receiving prefixes from BGP neighbor and if you are advertising them towards IBGP neighbor, then only it can work. But over here you can see that, you know, like 5.5.5 is there. So we need to configure this, I mean this next hop address as the tunnel interface address, right? So make it 192.168.1.2. You know what will happen then? Because its next hop address will become tunnel's address, and it will start sending traffic via tunnel. And once your traffic will start going through tunnel, which means that traffic will start delivering on destination. Right? So this is the way to solve this problem. So now I have configured tunnel interface. I'm gonna to configure one route map now. Route map, let's say its name is what? Next underscore hop, permit 10. By default match all is there. By default, if I do not match anything, then by default match all will be there, right? Then I can say set IP next hop, and that is what? 1.2. I can move inside the BGP 100. I can say neighbor 5.5.5 and route map, and the route map name was, and in which direction? Inbound direction, because all prefixes are inbound prefixes. So in all inbound prefixes, I want to configure their next hop address as the tunnel interface of R5. So whenever this router 1 will receive any BGP prefix, BGP update from its neighbor 5.5.5, it will configure its next hop address as per this route map. And in route map, I have already set its next hop address as 1.2, right? Then say do clear IP BGP star in. Now you see show IP BGP. Check it out. Now its next hop address is what? 1.2. Similarly, I will be doing on R5. Right now you can see its next hop address is 1.1.1, but we need to configure it as tunnel interface of R1, right? So that traffic will start going through the tunnel interface, right? So what can we do? We can say route map, and it is what? Next hop, and permit 10, and I can say set IP next hop, and that is going to be 192.168.1.1. You understand? After setting this next hop address, then you are required to move inside BGP 100, and you can say neighbor 1.1.1 route map, and route map name is what? Next hop, right? And then you can say in, because R5 is also receiving some prefixes coming from neighbor router 1. Then say do clear IP BGP star in, right? So that it will instruct to its neighbor to retransmit all the updates, right? Now you can look at this show IP BGP, right? It is now 1.1, and now you can try to ping 192.168.1 or 101.1 when source is your own lane. Still R2 and R3 they do not have, like you can move on R2, you do not have 101 and 105. You can look at like this, show IP route 168 101.0 or 10. So transit devices are still not having all those prefixes, but still they are forwarding that traffic because now traffic is going through the GRE tunnel. Understood? So in this way you can do this. Apart from that, if you do not want to configure this route map and all, I mean if you do not want to do some complex configuration, you want to do it in easy manner, you do one thing, say no router BGP 100, I'm gonna remove it from R5 as well. I'll be saying no router BGP 100, right? I'll move back again on R1 and I'll say no route map, and I think it was next underscore hop, right? Do show history. Similarly, I will remove it from R5. So now show route map, nothing. On R1, show route map, show IP, show IP route BGP. Does it have anything? No. So now what can we do? We can simply configure router BGP, and then in neighbor I will define simply 1.2. I'm not going to configure now BGP peering with using their loopback addresses. Now I can configure BGP peering between R1 indirect BGP peering in between R1 and R5 with using their tunnel interfaces itself, right? Remote AS is what? Fine. So now similarly I can move on R5 and I can say router BGP 100, and then I can say 1.1 and remote AS is going to be 100. Neighborship must come up, and then we can advertise 101 from here and 105 from here, right? You do one thing, move back again on R1, show IP BGP, you check it out. 102 will come over here, just wait for a moment. 102 will appear here. And next hop will be neighbors IP address automatically, and this time we formed neighborship between R1 and R5 with using their tunnel interfaces, right? So this time you are not required to configure any kind of route map or something like that. 105, right? Source is its own lane. So you can also do this.
Previous example we used
Route map to modify next hop.
Okay, right. On the receiving side of the routes.
Fine. So this is the way by which we can solve all these problems now. So on R1, once again I'm going to say no router BGP 100. Similarly I will remove it from R5. I will be saying no router BGP 100. Again I will move back on R1, and this time we will form indirect eBGP peering. This time we will form indirect eBGP peering. So I'll be saying router BGP 100, neighbor is 5.5.5 with using their loopback interfaces, right? Remote AS is going to be, let's say, 200, right? So I'll be saying neighbor 5.5.5 and update source is going to be loopback 1. Similarly, I will move on R5. I'll be saying router BGP 200 and then neighbor 1.1.1, remote AS is what? 100. Neighbor 1.1.1, update source is loopback 1. Right? Neighborship must come up. So IP BGP summary. It will remain in ideal state. Same problem, right? Because direct a BGP neighbor is not directly connected, so it is not going to initiate this neighborship. Now what can I say? Router BGP 100 neighbor 5.5.5 disable connected set. Similarly, I will move on R5. I will be saying 1.1.1 disable, but still they won't be able to form neighborship. You know why? Due to TTL. By default, TTL value is what? So that packets will be dropped by R2 itself, and you can see them. Let BGP send any message. It will definitely it will send SYN message, right? And then we will see that R2 will generate unreachable or something like that. TTL, I mean something like TTL. You see, TTL exceeded. Right? And TTL exceeded is given by R2 itself. But this time neighborship will remain at least in active state, right? So IP BGP summary. This time it is mandatory to change your outgoing TTL value. So router BGP 100 neighbor 5.5.5 and TTL security. So how many hop away it is? 4 hop away, right? You can check it out by saying to trace. 4 hop away, right? So neighbor 5.5.5 TTL security, sorry, not TTL security, eBGP multi-hop, not TTL security, right? First of all, let's go for eBGP multi-hop, and then after I'll be telling you TTL security. So eBGP multi-hop is what? 4. Similarly, I'll move on R5 and then I'll say neighbor 1.1.1 eBGP multi-hop is what? Then right, then you see router BGP 100 network 192.168.101.0. Similarly, I will move on R5. Right, check it out. So IP BGP. Both prefixes are there, but still next hop is what? 5.5. So again they will not be able to communicate with each other. However, it is learning, it's neighbors lane network, right? But still if you try to communicate with 105.1, it will be dropped by R2. And if you in source, if you take your own lane, then you won't be able to get this unreachable message. You know why? R2 will receive it, R2 will be giving unreachable message, but R2 even doesn't know about the lane of R1, so it won't be able to give this unreachable message back to R1. That is why this time it is showing you request timeout, because it is not getting host is unreachable message back from R2 to R2. Fine. So to solve this problem, again use route map, set your next hop, and this time previously I configured route map in inbound direction. This time I'm going to configure route map in outbound direction. See, prefixes are going towards R5. R5 has learned. You see, so IP BGP and to reach 101, its next hop is what? 1.1.1. R1 is giving this information, right? So what can I do? I can create a route map with the name of next permit 10 match. By the match all is there, set IP next hop 181.168.1.1, right? 1.1, and then router BGP 100, neighbor is 5.5.5, and route map name is what? Next. In which direction? Out. What are we instructing for this neighbor to this router? We are saying that whenever you will send any update to 55555, make sure that your next hop is going as 18. Sorry, yes, it is 181.168.1.1, right? Now do one thing, say do clear IP out. Do one thing, move back again on R5 and check its next hop now. So you can configure route map in both directions, inbound as well as outbound. So now again on R5, because R5 is giving its own lane to R1, you can check R1's even this time let's say that I don't want to configure in route map on R5. I just wanted to solve this problem by creating route map only on R1. So now I can apply another route map in inbound direction for this neighbor, right? I can create another route map. Next in permit 10 set IP next hop is what? Router BGP 100, neighbor route map next in which direction? In. Do show run pipe section router BGP. Check it out. I have configured two route map. One is inbound direction, another one is in outbound direction. Now say do clear IP BGP star in show IP BGP. Check it out. This is the point. So I have told you that how to modify next hop with the help of route map. आ जाओ सर, कोई नहीं सर, बस बीजीपी चल रहा है.
In this one, we are setting next hop for out routes. So 101 is also going on the right, but it is not changing. We set it for 92 or something.
Yes, I have set it up, and that is why on R5 101 is coming with that now. You see, with 101 automatically. By default, it was coming with 11111 because neighborship is in between 1111 and 55555. Right?
Since it is connected, it is showing 000 on the local.
No. For 101, it was showing me 111111.
No, our local
See, this is directly getting advertised. Yes, if remember in BGP, if next hop is 00, which means that it is self-advertised. And for that, weight is 32768, and because it is learned from its neighbor, that is why it is 0. Coming from EPC neighbor and coming after processing AS100, that is why AS100 is there, right? So this is the way, and we have performed all these practicals now. Let me tell you that in previous class even I told you that by default there is a IBGP rule, right? If you receive anything from your one of the IBGP neighbor, then you will never forward that information towards any other IBGP neighbor. You do one thing now, no router DICRP 100, no router BGP 100. वाटर
पेन ड्राइव
मेरे पास नहीं है किसी के पास पेन ड्राइव? पीछे होगी यहाँ इनके पास, ले लो। This time I'm gonna to put all of them in same AS. All of them will be having IPG pairing, right? Or let's do one thing here, AS 100 and on rest AS 200, right? So here I'll be configuring AS 100 and on rest AS 200. So now you see router BGP 100 neighbor 12.1.2, remote AS is what? Sorry, right, network 101.0. On R2 router BGP 200 neighbor, remote AS is 100, network 102.0. Along with that, neighbor remote AS is 200. On R3 router BGP 200 neighbor 23.1.2, remote AS 200, right? Neighbor 34.1.4, remote AS is 200, right? Network 103.0. Router BGP 200, neighbor remote AS 200, neighbor 45, network R5 router BGP 200, neighbor 45, remote AS is 200, network. Now here IBGP rule will take place automatically, right? Maybe BGP summary. Fine, so IBGP it is learning 1 or 2. Let's move on R2. So IBGP on R3. So IBGP 1 or 2 is there and 103 is there. Then it is not giving this 103 to this. Yes, 103 has came now, right? And then 103 must be available on BGP neighbor as well. Means that there is a rule in BGP that if it receives anything from its one of the IBGP neighbor, then it can forward all those prefixes towards eBGP neighbor automatically, right? If it is receiving anything from one of the IBGP neighbor. So that's the point. Then after we can see that R1 is giving its prefixes to R2, but R2 will not forward it towards R3. It will forward, but it will not change its next hop address, you see, right? So it is coming as 12.1.1.1. So to solve this problem, as I told you, on R2 you can say router BGP 200 neighbor 23.1.3 next hop self, right? Now we would see this output on R3 that we must get this 101 over here, but now this R3 received it from one of the IBGP neighbor. That is why this R3 is not gonna to forward it towards another IBGP neighbor, that is R4 this time, right? So to solve this problem, now we are having a solution over here, and that is called, route reflectors. So now I'm gonna to use route reflectors. See, route reflectors, we will learn about route reflectors, twice. Like now I'm gonna to teach you this route reflector, but at a small scale only, right? But at a large scale we will be learning about this route reflectors in future, right? I mean after some classes or in next class, or right? So now remember that with the help of route reflectors we can break that IBGP rule. With the help of route reflectors, we can break that IBGP rule, because by default rule says that if you receive anything from one of the IBGP neighbor, then you will never forward that information towards other IBGP neighbors. To solve that problem, here we are having this route reflector and the concept of route reflectors. Now in route reflectors we have three things: route reflector, client and non-client, right? This RR is also called as server, right? Client is client, non-client, non-client, right? Now there are some rules that client and client, they can exchange updates with each other. I mean, route reflector can exchange updates with the clients, right? Route reflector can reflect routes between clients, between client and non-client as well, but route reflector cannot reflect update between two non-clients. Route reflector, I mean server, cannot reflect routes in between two non-clients. But of course it is possible for server, it is possible for route reflector to reflect routes in between client and non-clients, right? So in route reflectors there will be three things: route reflector, that is also known as server, client and non-client. There are some rules available. Route reflector can reflect route between clients, between client and non-clients, right? But route reflector cannot reflect between two different non-clients. What does it mean? Which means that, let's say that we are having a diagram in this manner. This is router 1, this is router 2, router 3, router 4, and this is router 5, right? And you know your diagram in this manner. You define this R1 as a route reflector, you configure this R2 as client, you configure this R3 as client, and these of the R4 and R5 are still non-client. So now R1 will not exchange routes between R4 and R5. Apart from that, it will exchange routes between all neighbors. Like if it receive R1, if R1 is receiving anything coming from R2, it can forward that information towards R3 as well as towards R4 as well as towards R5 coming from R1, right? Sorry, coming from R2. Then similarly, if anything is coming from R3, then it can forward towards all others, right? Similarly, if anything is coming from R4, then it can forward towards only clients, right? Because this time it is coming from non-client, right? So it can forward that information towards clients only, but if it receive anything from one of the non-client, it will never forward that information towards any other non-client, right? Similarly, if it is receiving anything coming from R5, it will receive it and can forward towards R2 as well as towards R3, but will never forward towards R4 because it received it again from non-client. So it is not possible for route reflector to reflect routes in between non-clients. So I hope that you people have understood it now. Fine. So similarly, I'm gonna tell you over here, I mean, to solve this problem, because this time R3 is receiving from IBGP neighbor R2, so I'm gonna to configure this R3 as a route reflector now, RR, and I'll configure this R2 as a client and also R4 as a client. Now the point is, of course, if R3 is receiving anything from R2, it can forward it towards R4, but whenever R4 will receive anything from R3, then R4 will not forward that towards R5, right? So in that case, I will require to define this R4 as a route reflector as well, and then I will define this R3 as a client, and then also R5 will be defined as a client. So remember that one single router can be client along with server, right? So in this way, we will be taking prefixes from R1 to R5. So let's start it now. So right now R3 is not giving anything to R4. Does R4 have anything like 101 or 102? No, it does not have anything like that. But now I'm gonna to say on R3 that router BGP 200 my neighbor 2.2.2, or sorry, it is what, 23.1.2, and this is going to be route reflector client. Route reflector client. Once you configure any neighbor as a route reflector client, then you can also see here like 34.1.3, and it is also your route reflector. Sorry, this is what, 4, 34.1.4. It is also your route reflector client. So now this device will become server automatically. This device, see, if you configure this command, because you define that my neighbor is client, so which means that you are server. So this client, I mean this device will become server automatically. So now you can find all these prefixes available on R4. You can check it out. So IP BGP, yes, 101 is there, 102 is there, but still they are not best. You know why? Because their next hop addresses are not reachable. Their next hop addresses are not reachable. How can we solve this problem now? We can again create a route map, right? We can modify. See here, we cannot use next hop self command, right? So to modify route map, I'm gonna to create this route map. Let's say its name is test permit 10 set IP next hop, and that will be 34.1.3. And then I can move on inside router BCP 200. Say neighbor 34.1.3 route map name is test in which direction in say do clear IP BCP star in. Now check it out. Do show IP BCP. Your next hop will get modified, and now they will become best, because now these prefixes are best for R4, and now it will start forwarding these prefixes in the direction of R5 as well, right? So now you must be able to see them over here. Right? So now again we are not receiving anything on R5. You know why? Because R4 is not working as a route reflector. So R4 is receiving them from R3. So it is not gonna to forward anything towards R5. So now what can we do here? We can move on R4 and we can say 3, yes, is what? Route reflector client. Along with that 45.1.5 is also route reflector client. And now you must be able to see all of them on R5. Check it out. But again, none of them will be best, just because of next hop unreachability, right? So next hop is still not reachable, and that is why it is not possible. It is not possible to make them as a best path like 101, 102, and 103, right? So to solve this problem, I'm gonna to create this route map. Let's say its name is test and permit 10. Set IP next hop is going to be 45.1.4, and then after we can say router BGP is 200, neighbor is 45.1.4, and route map name is test in which direction in. Say do clear IP BGP star in. Do show IP BGP. Check it out. All of them are there. So in this way you will be taking your prefixes from one device to another device. So you have received all the prefixes on R5, but are you receiving everything on R3 now? So IP BGP like 105, is 105 there? Yes, it is, but it is not best, just because of next hop is not reachable. To make it reachable, again use route map. Similarly, you can move on R2. Some of the prefixes will not be available over there, and some of them are there, right? But you see that whenever it will give any prefix to its eBGP neighbor, it will give it after modifying its next hop address. You can check it out. Show IP BGP. Check it out. That 101, 102, and 103, these are coming, and next hop address is 112.1.2 automatically. So it has proved now that whenever updates will be forwarded towards eBGP neighbor, the next hop address will get changed automatically, will get update automatically. Any problem? Are you sure about it? So this is the way in which you can modify next hop address. You can solve the problem of BGP, right? So that's it. Once again, I'll move back on indirect neighborship. I'll let you know that what is the meaning by TTL security. Previously, I just performed that practical with the help of eBGP multi-hop, right? And this time we will be performing that practical with the help of TTL security.
प्रोडक्शन नेटवर्क में ये कैसे आइडेंटिफाई हुआ कि नेक्स्ट हॉप की वजह से इशू आ रहा है?
If you are receiving any prefix in your BGP table, right? Let's say that you are on R2, so I have a BGP, and this prefix is there, but it is not best, right? So first, what is the very first thing that you will check?
नेक्स्ट हॉप
Check its reachability. Show IP route. Simple. राउट मैप तो लगते हैं बहुत ज़्यादा होते हैं, बहुत ज़्यादा होते हैं. देखना कभी भी ISPN का जो राउटर होगा उस पर राउट मैप ही होंगे बस. जैसे फायरवॉल में आपकी नेटिंग और ACLs लगी होती है ना, ऐसे ISP राउटर्स पे राउट मैप लगे होते हैं BGP में. राउट मैप के अंदर 50-50 स्टेटमेंट्स आ जाती हैं, मतलब 50 सीक्वेंसेस या और भी उससे ज़्यादा। Fine. Let's go for EBGP multi-hop now. No router BGP 100. Similarly, I will be removing it from R2. Once again, I'll be configuring ELCRP, right? Router, network, fine. Once again, EBGP neighborship between R1 and R5. I'll be saying router BGP 100, neighbor is 5.5.5, remote AS is 200, right? Neighbor 5.5.5 in update, source, take loop back 1. Similarly on R5, router BGP 200, neighbor is going to be 1.1.1, remote AS is going to be 100, neighbor 1.1.1, use update sources loop back 1. But you know very well that BGP summary will remain in ideal state. To solve this problem, now you have to configure TTL value, right? But I mean EBGP multi-hop command. But apart from that, you can also use TTL security. Remember that out from EBGP multi-hop and TTL security, you can use only one option. You can configure either EBGP multi-hop or TTL security. If you are going to configure TTL security, you just need to know that how many hop your neighbor is. How many hop away your neighbor is, right? So this time your neighbor R5 is just 4 hop away from R1. So we can simply say that neighbor 1.5.5 TTL security, right, hops, and how many hops away it is? 4. Similarly, I will move on R5 and then I'll be saying neighbor 1.1.1 TTL security hops is what? 4, right? So because my neighbor was just 4 hop away from R5, right? So after configuring this TTL security, what happens? Remember that once you will configure TTL security for any neighbor, in all outgoing messages it will start configuring its TTL value as 255. This is the very first change. After configuring TTL security in all outgoing packets, it will set its TTL value as 255, right? But along with that, it will also set one another condition, that if I receive anything from this particular neighbor, if I receive any packet, BGP packet from this neighbor, let's say that I'm on R1, I'm on R5. So if R5 receives anything, any packet coming from R1, that must not have TTL value, that received packet must not have TTL value lower than 251. Lower than 251. Even you can look at this now on R5. And look at this IP BGP neighbor. Check it out. Outgoing TTL and minimum incoming TTL is what? 251. And what does it mean? That if packet is coming from R1 only, because R1 is just 4 hop away, right? So if packet is coming up from R1, then the TTL value till me, right, it must be 251. And if it is lower than 251, if it means that someone else is trying to send me BGP packets. Someone else, right? Yes, your attacker can exist in between these devices, but this TTL security does not prevent from those attackers which are existing in between neighbors, EBGP peers. But if your attacker is behind R1, then definitely that attacker won't be able to spoof our IP address and will not be able to use our BGP peer, because this time minimum, here you can see minimum TTL is what? 251. Any problem? So this is called TTL security. So if anyone outsider spoof your IP address and tries to destroy your eBGP peering or try to send some bogus updates, your device won't accept that, because here is limitation. If any packet is coming, if any BGP packet is coming, it must have its minimum TTL value as 251. That's the minimum, right? And if any attacker that is more than 4 hop away, of course if packet is coming from there, then TTL value will be lower than 251. I hope you people have understood now TTL security, right? So it is better than eBGP multi-hop, because in eBGP multi-hop, minimum incoming TTL value is 0. In case of if you use eBGP multi-hop command, then minimum incoming TTL value is 0. But in TTL security, it will be depending on that how what you configured in TTL security. Like if you configured 4, which means your neighbor is just 4 hop away, so it will be expecting that in received packet minimum TTL value must be 251. That's it.
So in multi-hop BGP, per neighbor is maybe 3 hops, and if we say 4 or 5, whatever number, still it won't affect, right? Because outbound, it should be less than the number of hops.
What? In eBGP multi-hop, you just need to define your outgoing TTL value, right?
Right.
But minimum incoming is 0. Which means if someone have spoofed your IP address and that attacker is trying to send some update packets towards you, you can easily accept that.
Right. So I'm saying that if we don't know the exact number of hops, and if we say maybe 10,
then you can define anything. But make sure that
it should be more than,
of course, or equal to.
equal or
Yeah. Fine, guys. So this is the end of the basics of BGP. Now we have covered all the basics of BGP. Now we will start doing perform practicals of BGP with using this topology, and today you will simply draw this topology. We will not perform any practical related to this topology. This is going to be this. This is going to be your new topology now for BGP, right? So we will be using this topology for performing practicals of BGP. Here we are having two ISPs, Sprint is there, BT is there. There is a customer running IGP inside it, like OSPF is running, is having 3 internet connections, 3 links are there, 2 links are coming from BT, 1 link is coming from Sprint, and then there is a customer sitting in New York, and that customer has taken connection from BT only, right? And with using this diagram, we will perform all the practicals available in BGP. So we can perform all the practicals of BGP with using this diagram now. I'm not saying that you must draw the exact diagram, but that it should be something like this. And usually you will find this kind of scenarios. Like this is your enterprise network. On edge routers you will be running BGP. Internally you will be running IGPs, right? That's what you will do actually.